Hi everyone, it's me Indra. Welcome back to my channel. Today in this video, I will calculate the derivative of ln of x with respect to x. Please watch this video till the end so that you will get the solution of how to calculate the differentiation of ln of x with respect to x, as well as some basic concept of the derivative of a function. And if you don't subscribe my channel yet, please subscribe it and press the bell icon for instant notification of the uploaded videos. Without wasting any further time, let's get started. Here I have taken a function here. Let's say this is f of x, it is the function of x. Here this is ln of x, and we are going to evaluate its derivative with respect to the input variable x. Before moving to the differentiation of this function, let's define the derivative of a function. Derivative of y with respect to x is defined as the limiting value when the delta x approaches to 0 of the function f of x plus delta x minus f of x all over delta x. Please remember this basic definition of the derivative of a function. This is called as the first principle method, or it is also called as the definition method for the derivative of a function. It is just the limiting value of this function. And here in this question, our function is just ln of x. So let's calculate the limiting value when the delta x approaches to 0. Here f of x plus x, this is f of x, and the f of x plus delta x is obtained just replacing x by x plus delta x. So our function will be ln of x plus delta x minus f of x is here just ln of x, it is divided by delta x. Here we just substitute the value of f of x and f of x plus delta x, and let's simplify this. Limit when delta x tends to 0, and here in numerator we can apply the quotient law of the logarithm. And this can be written as ln of the first number is here x plus delta x divided by the second number is here x. Here we just apply the quotient law of the logarithm. It is divided by delta x. Here we just apply the log a minus log b. It is just log a over b. Here we just apply this formula. Log a minus b is log a over b. This is called as the quotient law of the logarithm. And let's simplify this. Limit delta x approaches to 0. Here ln of, we can distribute the common denominator, and this can be written 1 plus delta x over x all over delta x. Here we just distribute this x. Here we just distribute this fraction into the two parts. And remember very important property of the limit of a function, limit of a ln of f of x. Let me write here something about one very important property of the limit. Limit of ln of f of x when the x approaches to a constant number a. Limit of ln of f of x is same as ln of the limit of that function. Limit of that function. It is very important property of the limit of a function. Limit of ln of f of x is same as ln of limit of that function at the same point. We can use the same concept here. And before using this concept, let's write here, this can be written as delta x approaches to 0 ln of 1 plus delta x over x, and this 1 over delta x can be written on the power. This can be written as, here we just apply the power law of the logarithm, this 1 over delta x. Here we just apply the formula a times log b is just log b raised to the power this a. here the coefficient is here 1 over delta x, and it goes to the power by using the this law of the logarithm. And here we can use this concept, here we can use this concept in this step. limit of limit of sorry ln of the limit of that function. Limit delta x approaches to 0 of the function is here 1 plus delta x over x, it is raised to the power 1 over delta x. Here we just use this property of the limit of a function, and this can be further written ln of, and here there is a very beautiful form inside this square bracket. Let me write something about the Euler number. The Euler number E, it is an irrational and transcendental number. It is defined as limit when the variable delta x, let's say the delta x here, delta x approaches to 0, 1 plus that variable delta x raised to the power of reciprocal of delta x. It is the definition of the Euler number. Limit delta x approaches to 0, 1 plus delta x, all raised to the power 1 over delta x. It is the definition of the Euler number. And the Euler number here, if the coefficient here, the e raised to the power of a, let's say e raised to the power of a, it is defined as the limiting value when the delta x approaches to 0 of the function 1 plus a times delta x raised to the power of 1 over delta x. It is when e raised to the power of a, is just here the coefficient, making the coefficient of the delta x is a. Here a is the coefficient of the delta x, all same, only changing in the coefficient. Here the coefficient was 1, here the coefficient was, here we make the coefficient is a, so we have to give the power a. Here we can apply the same concept here. This is here the coefficient, the limit delta x approaches to 0, and this here 1 plus 1 over x times the delta x. Here the coefficient of the delta x is 1 over x raised to the power of 1 over delta x. This can be further simplified as this, and this can be further written as ln of, this is here just e raised to the power of, here the coefficient of the delta x is here 1 over x. Coefficient of the delta x, here the coefficient of the delta x was a, so e raised to the power of a. Here the coefficient of the delta x is 1 over x, so e raised to the power of 1 over x. And we can simplify this. This can be written as 1 over x ln of e, just using the power law, just using this rule. And 1 over x times ln of e is just 1. So the derivative of y with respect to x is here over as 1 over x. Here, therefore we can conclude that derivative of ln of x with respect to x is just 1 over x. Here we finally prove this formula. Please remember that the derivative of ln of x with respect to x is just 1 over x. In our next video, we will discuss more about the derivative of the function. Please keep watching, keep loving this channel. This much for today. Thank you.